Welcome to the video presentation of Andhra Pradesh State Syllabus 9th Class Social Chapter 3 The Hydrosphere. Now let us have an idea about the different spheres on Earth. First one, lithosphere, that is the solid Earth, that is the soil, especially soil, rock and everything. Second sphere is the hydrosphere, that is the all water found on or under and over the surface of the Earth. Third sphere is the atmosphere, the gases that surround the Earth, that is the air. Now the fourth sphere, that is the biosphere, it is the area of life. So you will study about each and every sphere in detail in this year. In this chapter, we are going to study about the hydrosphere in detail. The hydrosphere is part of the Earth that is liquid water. It includes the water in lakes, rivers, marshes, clouds, rain, and even water found underground. Oceans cover 71% of the Earth's surface. 97% of all water on Earth is salt water that we can see in the oceans. The word hydrosphere comes from the Greek word hudor. The meaning is water. Now look at this picture. What do you see here? Yes, it is a hydrological cycle. Otherwise it is known as water cycle. Here you can see the different steps of the water cycle like evaporation, precipitation, transpiration, and even transportation through clouds, etc. We'll study about that in detail. Now let us see how we can express the hydrological cycle in mathematical way. That is, RF is equal to RO plus ET. In that, RF is the rainfall, RO is the runoff, ET is the combination of evaporation and transpiration, that is otherwise known as evapotranspiration. There are 6 stages in water cycle. The first one, evaporation. The water turns into vapor is known as evaporation. Second, transportation. The turned water vapor will be transformed into clouds, and that clouds move from one place to another, that is known as transportation. Third one, condensation, that is the cooling of the clouds, that is known as condensation. Then fourth, precipitation. The clouds will again turn into water in the form of rain or snow, that is known as precipitation. After that, runoff, that is water will fall on the earth and it will move from one place to the another place, that is known as runoff. Then some water will be percolated to the underground, that is known as groundwater. Now let us learn in detail about evaporation. Evaporation is one of the two forms of vaporization. It is the process whereby atoms or molecules in a liquid state gain sufficient energy to enter the gaseous state. It is the opposite process of condensation. Due to heat, the water turns into vapor. That means water turns into air-like model, that is known as the vapor, that is evaporation. Now let us see from where the evaporations happens. Evaporations happens everywhere, especially from land, lakes, rivers and oceans send up steady stream of water vapor. Now let us see examples of evaporation in our daily lives. For example, when we dry clothes, drying hair, drying agricultural products, drying fish and prawn, cooling the body, producing the common salt, etc. are some of the examples of evaporation. When we cook also, evaporation happens. Now let us see what is transpiration. The plants and animals release water vapor to the air, that is called transpiration. Here you can see the transpiration is the loss of water from a plant in the form of water vapor. Water is absorbed by the roots from the soil and transported as a liquid to the leaves via xylem. In the leaves, small pores allow water to escape as a vapor. Here the picture, it is clearly, you can see that one. Water is absorbed by the roots, then it is moved through the trunk to the leaves, and from the leaves the water evaporates, that is known as transpiration. Now let us learn about transportation. In the hydrological cycle, transport is the movement of water through the atmosphere, specifically from over the oceans to over the land. Some of the Earth's moisture transport is visible as clouds, which themselves consist of ice crystals or tiny water droplets. Here you can see the water evaporates and the water vapor condensed, then clouds are formed. These clouds are transported from one place to the another place. Here we are going to learn about condensation. Condensation is what happens when the water vapor changes from gases to liquid state. As warm air cools, the molecules in the water vapor move closer together and the vapor becomes liquid. This process is known as condensation. Now let us learn about precipitation. Precipitation is water released from clouds in the form of rain, freezing rain, sleet, snow or hail. Now let us learn about runoff. The unabsorbed water from rain, snowmelt, irrigation or other sources which returns to land flows down hills as runoff into a watershed. This flowing of water through the downhill is known as the runoff. Now let us see what is groundwater. Groundwater is nothing but the water underground. So how it reaches there? Let us see that. The groundwater recharge occurs when surface water either from direct precipitation or from rivers and lakes percolates downwards through the microscopic spaces in the soil and rock profile. Thus it reaches the underground and forms the groundwater. Now let us see where and how the groundwater is stored. Here in this picture you can see that the groundwater is stored in the tiny open spaces between rock and sand, soil and gravel. Groundwater is stored in and moves slowly through moderately to highly permeable rocks called aquifers. The word aquifer comes from two Latin words, aqua means water and ferre means to bear and carry. Aquifers literally carry water underground. Here you have to notice that the flow of groundwater is much slower than runoff. Observe the picture. This will give you a clear idea about the different stages in the water cycle or the hydrological cycle. Now let us discuss about the accessibility of pure water on Earth. 68.7% of the pure water is in the form of ice and snow. 29.9% of pure water is in underground. 1.4% of the pure water is in the form of rivers, lakes and reservoirs. This is the profile of pure water on Earth. This picture will give you a clear idea about the water profile on Earth. The total water, 97% is saline water that we can see in the oceans and only 3% water is fresh water. In the fresh water, 30.1% is groundwater and 68.7% is in the ice caps and glaciers and 0.30% is surface water and 0.9% in others. And in the surface water, 87% of the water is in the lakes and 2% of the water is in the rivers and the remaining 11% swamps. And here This table will give you a clear idea about the total water percentage on the earth. The oceans comprise of 97.25%, ice caps and glaciers consist of 2.05%, groundwater consists of 0.68%, lakes contains 0.01% of water, soil moisture contains 0.05% water, atmosphere contains 0.001% of water, rivers contain 0.0001% of water, and biosphere contains 0.00004% of the water on the earth. Let us learn about oceans. The huge water bodies are called oceans. Here in this picture, you can see the 7 continents and 5 oceans. The 7 continents are Asia, Africa, Europe, Australia, North America, South America, and Antarctica. The 5 oceans are the Pacific Ocean, the Atlantic Ocean, the Indian Ocean, Southern Ocean or Antarctic Ocean, and the Arctic Ocean. Here this table will give you a clear idea about the location of the 5 oceans. The Pacific Ocean separates Asia and Oceania, that is Australia, New Zealand, Papua New Guinea together from the America. Secondly, the Atlantic Ocean separates the America from Europe and Africa. Third, the Indian Ocean washes upon southern Asia and separates Africa and Australia. Fourth, the Antarctic Ocean, sometimes considered an extension of the Pacific, Atlantic and Indian Oceans, which encircles Australia that is the Southern Ocean. And finally, Arctic Ocean, sometimes considered a sea of the Atlantic, which covers much of the Arctic and washes upon the North America and Eurasia. The ocean floor is divided into 4 parts: continental shelf, continental slope, sea plain, and trenches. Now let us learn about continental shelf. A continental shelf is a portion of a continent that is submerged under the area of relatively shallow water known as a shelf sea. A continental shelf typically extends from the coast to depth of 100 to 200 meters, that is 330 to 660 feet only. Here in this picture you can see this is the continental shelf. Continental shelf is the border zone. The largest continental shelf is the Siberian shelf in the Arctic Ocean, stretching to 1500 kilometers in width. Now let us learn about the continental slope. Continental slope is the deepening of sea floor out from the shelf edge to the upper limit of the continental rise. It is about 200 meters to 3000 meters depth. Here it is the continental shelf. From there, the continental slope starts until the continental rise. Now let us learn about sea plain. It is otherwise known as abyssal plain. It forms much of the floor under the open ocean. It lies from 3 to 6 kilometers below the surface of the ocean. Much of it is flat, that is why it is known as abyssal plain. Now let us learn about trenches. An oceanic trench is a deep canyon on the ocean floor. They are long, narrow, steep-sided depression in the ocean bottom in which occur the maximum oceanic depths, approximately from 7,300 to more than 11,000 meters. Major deepest ocean trenches. Almost all the deepest trenches are found in Pacific Ocean, and the deepest ocean trench in the world is Mariana Trench, which is having 10,984 meters depth. Second one, Tonga Trench in Pacific Ocean with 10,882 meters depth. Third, Philippine Trench, in the Pacific Ocean with 10,545 meters depth. The other major ocean trenches in the other oceans are Puerto Rico Trench with 8,400 meters in Atlantic Ocean, Java Trench with 7,192 meters in the Indian Ocean, South Sandwich Trench with 8,266 meters in the Southern Ocean, and Molloy Hole with 2,700 meters in the Arctic Ocean. Now let us learn about salinity. Total amount of dissolved salt in the seawater is known as the salinity. It is measured in parts per thousand, that is known as ppt. The average value is 35 ppt or 35%. The salinity ranges from 0% near the river mouths to 40% in the Dead Sea. Globally, seawater salinity remains constant. Rule of constant proportion states that the percentage of various ions in the seawater remains constant. Now let us see what are the constituents of ocean salinity. We have already learned that the average seawater salinity is 35%. The main constituents of ocean salinity are chloride, sodium, sulfate, and magnesium. Salt is produced by the evaporation of seawater. It is used as a seasoning in foods, cooking, cosmetics, and for preserving food. It is also called bay salt, solar salt, or salt. Its chemical name is sodium chloride. Now let us see what is salinity. Salinity is the dissolved salt content of a body of water. Look at the diagram to the right showing the varying degrees of salinity in the water. Brine water. It contains 50 plus ppt. Saline water, that is the sea water or salt lakes water, contains salinity in between 30 to 50 ppt. Now brackish water, that is mangrove swamps, blackish seas, lake, etc. contains 0.5 to 30 ppt of salinity. Freshwater, ponds, lakes, rivers, streams, aquifers, etc. contains 0 to 0.5 ppt of salinity. Here you can see the water bodies with highest salinity in the world. The number one position goes to Lake Van in Turkey with 330% of salinity. Second, Dead Sea, it is in Israel, it's about 238% of salinity, and Great Salt Lake of USA has the salinity of 220%. Here you can see the map of the Lake Van, that is in the Turkey. Here you can see the real picture of Lake Van. Here in this map you can see the location of Dead Sea. The sea is called dead because its high salinity prevents macroscopic aquatic organisms such as fish and aquatic plants from living in it. The Great Salt Lake, located in the northern part of the United States in the state of Utah, is the largest saltwater lake in the Western Hemisphere and the fourth largest terminal lake in the world. Here you can see in this map the location of the Great Salt Lake. Here in this picture you can see a kid is floating on the water in Great Salt Lake. How it happens? When salt is dissolved in water, it makes the water denser than it would be without salt. As long as the density and salinity is high enough, you can float in any large body of salt water. Here you can see a real picture of Great Salt Lake of USA. Now let us see the water bodies with the lowest salinity. They are Baltic Sea and Hudson Bay with 3 to 15% of salinity. Here in this map, you can see the location of the Baltic Sea. Here in this map, you can see the location of the Hudson Bay. Here we learn about isohaline. Isohaline is an imaginary line on a map that connects all the points of the ocean with the same salinity. Iso means same and haline means salinity. Thus, isohaline joins all the points or contours having the same salinity in an aquatic system. Now let us learn about ocean temperature. The average temperature of the ocean surface water is about 17 degrees Celsius. The highest temperature is recorded in Red Sea, that is 38 degrees Celsius. Now let us learn about the flow of ocean water. The ocean water is constantly in motion, north to south, east to west, along shore and vertically. Seawater motions are the result of waves, tides and currents of ocean movements are the consequences of many separate factors like wind, tides, Coriolis effect, water density differences and the shape of the ocean basins, etc. Now let us learn about ocean currents. The ocean currents may be classified based on temperature as cold currents and warm currents. Now let us see what is drift. The ocean water current which flows slowly is called drift. Here we are going to learn about the El Niño. El Niño is an abnormal weather pattern caused by the warming of the Pacific Ocean near the equator of the coast of the South America. The sun warms the water near the equator, which can make more clouds and therefore more rain and sometimes causes harmful weather conditions. El Niño is a Spanish word meaning the little boy. Now let us learn about La Nina. La Nina is a coupled ocean atmosphere phenomenon that is the colder counterpart of El Niño. A cold ocean current of variable force that develops after the coast of Ecuador and Peru and sometimes causes harmful weather conditions. La Nina is a Spanish word meaning the little girl. Let us now compare the El Niño and La Nina. El Niño is an irregular event of warming of Pacific waters, occurs at intervals of 2 to 7 years. La Nina is a cold episode that usually follows the warm equatorial ridge cools between the coasts of South America and Oceania. The effects on climate. Due to El Niño, the warm currents flowing towards the east displaces the cooler currents to Oceania. Rainfall occurs over central and eastern Pacific and drought in Indonesia and Australia. The effect of La Nina is the currents contribute to form a warm pool in Oceania. Increased rainfall in Asia and Australia lower the temperature on the American coast and increased aridity. Here we are going to learn about the causes of ocean currents. First, centrifugal force. Second, effect of winds. Third, precipitation. And fourth, solar energy. Now let us learn about the centrifugal force. The centrifugal force is the apparent outward force on a mass when it is rotated. Here in the picture you can see that when it is rotating in circle shape, a centrifugal force will force you to move on this direction. But it should move on this way. So this effect is known as the centrifugal force. Think of a ball on the end of a string that is being twirled around, or the outward motion you feel when turning a curve in a car. So the centrifugal force at the equator is greater than that at the poles. Thus the equatorial water move towards the poles. This is the effect of the centrifugal force on the ocean water. The second force that causes ocean current is the effect of the winds. Water is dragged along the wind direction. The third force that causes the ocean current is the precipitation. You have already learned about precipitation. Precipitation is the water released from clouds in the form of rain, freezing rain, sleet, snow, or hail. The fourth factor that causes ocean current is the solar energy. The sun warms up parts of the oceans. Warm waters rise just like warm air rises. So as the warmer ocean waters begin to rise in a particular area, the cooler ocean waters from a different area will move in to replace the warmer ocean waters, and this creates ocean currents. The ocean water is about 8 centimeter higher in level near the equator than in the middle latitudes. We all know that ocean is a resource. Human beings have depended on oceans for their food and livelihood from ancient times. Oceans provided abundant food resources like fish and salt. We also use the sand and gravel that we receive from the seashore. Ocean waves are used for generating power. Ocean floor is mined for oils like petrol and diesel. Oceans provide gems and pearls. Let us summarize what our world ocean provides. The air we breathe, 50% of the oxygen is provided by the oceans. It controls the climate regulation, and it is one of the ancient means of transportation. It provides recreation, it contributes to the economy, provides food and medicine, etc. So the ocean is very useful for human beings. Even then, today oceans have also fallen victim. Whales have been disappearing. Oceans have also become dumping ground for our plastic and other forms of waste. In order to remember the importance of oceans, World Ocean Day is celebrated on June 8th every year. Let us see what are the problems faced by our oceans. They are plastics, trash, pollution, overexploitation of fishing resources, unsustainable aquaculture, marine engineering and oil drilling, destruction of habitats, ocean acidification and coral bleaching, global warming, etc. are some of the major problems faced by our oceans. Here is a project for you. You have to prepare a list of currents which are found in the Pacific, Atlantic and Indian Oceans. Identify the cold currents in different oceans. Dear learners, hope you understood this session very well. Thank you for watching this video presentation.